An autonomous photovoltaic system must provide the required electrical energy to adequately satisfy the energy demand, even during periods when there is no corresponding solar radiation. Such periods include nighttime hours and cloudy days. The only way to achieve this is by using an electrical accumulator. So stay with me in this video because we will be talking about electrical accumulators.
Soulios Consulting. Vassilis Soulios here. I help engineers increase their income by creating engineering services and services related to photovoltaics and heat pumps.
When a photovoltaic system is connected to the power grid, it has the ability to draw the required supplementary electrical energy from it, but also to feed back into the grid any surplus of generated electrical energy when the latter exceeds consumption demands. The capability for the above energy exchange does not exist in standalone photovoltaic systems. The need to store the surplus of their electricity production so that it can be used when production does not meet demand is met by special devices called electric accumulators or batteries. It is obvious that the total amount of stored electrical energy in a given system primarily depends on the maximum number of possible consecutive cloudy days and the peak energy consumption. Usually, energy autonomy is required for about 3 to 10 days. An electric accumulator is made up of pairs of metallic electrodes that are carefully connected in series, which are usually in the form of plates and are completely immersed in an electrolyte solution. Each pair of electrodes is called a cell. Depending on the material of their electrodes, electric accumulators are classified into many types, for example, lead, nickel-cadmium, nickel-zinc, silver-zinc, and so on. The most popular accumulator, known since the beginning of the previous century, widely used in submarines and automobiles, and which is the most economical for use in photovoltaic systems, is the lead-acid accumulator. That is the accumulator, which is a type of battery whose lead electrodes are completely immersed in a solution consisting of sulfuric acid, is being referred to here. A nominal voltage of about 2.35 volts develops at the terminals of a cell. Thus, a lead-acid battery with 6 cells has a nominal voltage of 12 volts and with 12 cells, 24 volts. These are the typical nominal voltages at which these specific batteries are commercially available in their well-known commercial form. However, in photovoltaic systems, batteries with dozens of cells in series are often used, so that they have a nominal voltage of 200 to 300 volts.
Conclusion. If you want to be the engineer who offers solutions and not just products, then specialization is the only way. So, if you want to learn about other aspects of photovoltaics, about the minimum distance between panels, about partial shading, and everything else related to the entire study, then this is the only way to be able to offer solutions. And if you're interested in learning how to do it correctly and offer photovoltaic solutions step by step with real tools and simulations, then take a look at our free courses. You will find them at the link below this video.